Hey guys, today we're going to work on scale drawing some more. This time we're going to work on solving for scale factor. This is something you will definitely see on your state testing and on map testing, where it's asking you for the scale factor. Today's lesson still goes right along with IXL. Today's will be J10 in IXL, and today's problems also come straight from that lesson that you're going to use for your assessment. So in example 1, it says Ruth measured a house and its lot and made a scale drawing. The scale of the drawing was 3 millimeters equals 1 meter. What is the drawing's scale factor? I will tell you that I put a hint in every problem that we're doing here in our practice questions. I would write these down if I were you before you do the assessment, because IXL is not going to give you this information here that I have highlighted. So you probably should write that down to kind of use like as a reference sheet. If you were to come across a question on IXL that you don't know this conversion here, then you're welcome to Google it and find out what the conversion is. I hope that I have put an example of every type that they're going to use in here. So hopefully I have. If I've not, then you're welcome to Google that. But 1 meter is equal to 1,000 millimeters. Please write that down somewhere. Now, when you're finding scale factor, your answer should not have any units in it. And by units, I'm talking about meters, millimeters, centimeters, inches, feet, things of that nature. Yesterday, whenever we done this, we would write our ratio, and then we would set it equal to another ratio, making it a proportion. And if we had started with, say, inches on the top, then we kept inches on the top. Today, we do just the opposite of that. We write it diagonal from it so that it cancels out and does not have any units. Okay, so remember, anytime it is asking for the scale factor, it does not have any units. Okay, so in this one, we're being told that the scale of the drawing was, I'm sorry, change that real quick for you. The scale of the drawing was 3 millimeters was 1 meter. Okay, so I'm going to write that down. So 3 millimeters was 1 meter. Now, like I said yesterday, we wanted to keep millimeters on the top. This time, we're trying to cancel those out. So I'm going to put millimeters on the bottom and meters on the top. And then I'm going to use this information here that I've highlighted that I told you to write down. So I'm going to use that to fill it in. So 1 meter and 1,000 millimeters. So now, when my units are opposite like that, they cancel each other out. So I'm going to multiply straight across here. So 3 times 1 is 3. And 1 times 1,000 is 1,000. And notice it tells us to simplify our answer and write it as a fraction. Okay, so have we simplified 3 over 1,000? 3 will not go into 1,000, so that means it is indeed simplified, which means our answer would be 3 over 1,000. Okay, again, you're going to need this information, so make sure you're writing it down somewhere. This 1 yard equals 36 inches. Write that down. You're kind of making a reference sheet as we're going through these problems today. So 1 yard equals 36 inches. It says Mandy measured a picnic area near the river and made a scale drawing. The scale of the drawing was 5 inches equals 1 yard. What is the scale factor of the drawing? So remember, anytime we're doing that scale factor, we don't want any units. So I'm going to use what I've highlighted in yellow. 5 inches is equal to 1 yard. And again, since I don't want any units, I'm going to write my inches on the bottom this time so they'll cancel out, and my yards on the top. And again, I'm using what I've highlighted in green there at the bottom, that hint. 1 yard is equal to 36 inches. So again, my inches will cancel out now because they're diagonal, and so will my yards. So I'm multiplying straight across now. 5 times 1 is 5. and 1 times 36 is 36. And you have to write it in simplest form or it will count it wrong when you do this on IXL. And of course 5/36 is already in simplest form. Okay, so we're going to need the hint down here. Make sure you write this down on your reference paper so that you'll have it when you do IXL. 1 meter is equal to 1,000 millimeters. You may already have that written down, but make sure it's there. 1 meter is 1,000 millimeters. Okay, go ahead and pause your video now, and let's see if you can solve example 3 and find the drawing scale factor. It says Angie measured a summer camp and made a scale drawing. The scale of the drawing was 1 millimeter equals 6 meters. Okay, so we're going to write that in a ratio. 1 millimeter was 6 meters. Remember, since we're doing the scale factor this time, we're going to write our units opposite so they'll cancel. I'm going to use what I've highlighted here in yellow. 1 meter is 1,000 millimeters. So my units cancel because they're written diagonal from each other. And we're going to multiply straight across. So 1 times 1 is 1. And 6 times 1,000 is 6,000. And that is in simplest form. Okay, so you're going to need that 1 yard is 36 inches. So if you've not written that down, make sure you do. And pause your video and find the scale factor. So the scale she used was 8 inches equals 2 yards. So we're going to write that as 8 inches over 2 yards. Inches on the bottom and yards on the top. And we want 1 yard is 36 inches. I'm using what I've highlighted in green there. My units will cancel. So I'm going to multiply straight across. 8 times 1 is 8. And 2 times 36 is 72. Now I can simplify 8 over 72. So 8 divided by 8 would give us 1. And 72 also divided by 8 would give us 9. So your scale factor would be 1/9. Okay, you need to make sure you've written this down. 1 meter equals 100 centimeters. Haley measured a neighborhood park and made a scale drawing. She used the scale 3 centimeters equals 1 meter. So we're going to write that as 3 centimeters over 1 meter. We want our units to cancel out for scale factor, so I'm going to write them opposite of each other this time. And I'm going to use our hint down here that 1 meter is 100 centimeters. And those will cancel my units now. And I'll multiply straight across. 3 times 1 is 3. And 1 times 100 is 100. And I cannot simplify that, so that is my scale factor, 3/100ths. Okay, make sure you write down 1 yard is 36 inches. And go ahead and pause your video and solve example 6. So the scale she used was 1 inch equals 1 yard. So we're going to write that as 1 inch over 1 yard. And to cancel out my units, I will write them opposite this time. And I'm going to use my hint that 1 yard is 36 inches. Units are canceled. 1 times 1 is 1. And 1 times 36 is 36. So my scale factor is 1/36. Okay, you'll need to write down that 1 foot is equal to 12 inches. And then pause your video and solve example 7. It says Darren made a scale drawing of the auditorium. The scale he used was 4 inches equals 8 feet. So what was the scale factor? So 4 inches is equal to 8 feet. We're going to write our units opposite this time because we cannot have units in a scale factor answer. I'm going to use my hint there that 1 foot is equal to 12 inches. Those will cancel. So 4 times 1 is 4, and 8 times 12 is 96. Both of those are divisible by 4. So 4 divided by itself is 1. And 96 divided by 4, you may have to go out to the side to divide that. 4 goes into 9 twice, gives you 8 with 1 left over. And then 4 into 16 is 4, which gives you 16. So it gives us 1/24. Go ahead and pause your video and solve example 8. Colin made a scale drawing of the auditorium. He used the scale 4 inches to 8 feet. So I'm going to write my units opposite so that they'll cancel. 1 foot, 12 inches. Four times 1 is 4. 8 times 12 is 96. And guys, this is the same problem again, and this may happen a lot of times with your IXL problems. So I really suggest that you write this down on paper because sometimes it's going to do you a favor and it's going to come back up again. So the scale factor, of course, 1/24. Okay, go ahead and pause your video and solve example 9. So the scale of the drawing was 3 centimeters to 1 meter. We're going to put the meters on the top and centimeters on the bottom this time so that they'll cancel. And we know that 1 meter is 100 centimeters. Our units cancel. 3 times 1 is 3, and 1 times 100 is 100. And that is in simplest form, so our scale factor is 3/100. Okay, pause your video and try example 10. It says Sam drew a scale drawing of a swimming pool. The pool, which is 10 meters wide in real life, so 10 meters, is 5 centimeters wide in the drawing. So we're going to flip those. 1 meter is 100 centimeters. Our units cancel. 10 times 100 is 1,000. And 5 times 1 is 5. And those can be simplified by dividing by 5. So 5 divided by 5 would be 1. And 1,000 divided by 5 would be 200. Now, I did not tell you this in the beginning because most of the problems are not set up for this to be a problem. However, our answer really is not 200 over 1. And if you enter that, it's going to count it wrong. Your units that's on the top here, where we had meters, let me rewrite that for you here. So we had meters and then centimeters. You want your smaller units on the top. So obviously centimeters is much smaller than meters. So we should have actually flipped that and put the centimeters on the top. But the only thing that means is that we can flip this answer here to where our scale factor is 1 over 200. Okay, so it's probably not a big deal on most of the problems, but you should not have an improper fraction, which is what that one actually was here that I've highlighted in green. That's actually an improper fraction, and your scale factor would not be an improper fraction. So you just flip that over to 1 over 200. And the way to prevent that is when you're setting up your problem like here, is to put your smaller units on the top, which in this case would have been the centimeters. All right, guys, that completes today's lesson. Your assessment, IXL J10. I won't continue to repeat that your SMART score is your grade and get it as high as you can, and don't work 300 questions to get to a 100. Reach out to me if you need me. Have a good one, guys.